This is it's called the Inclusion Exclusion Principle in set theory. I wanted to explain it pictorially because a lot of books they show it as just the formula, and it can be a little bit confusing as to why things work the way they do. So the Inclusion Exclusion Principle states that A union B, take the cardinality of A union B, they state that it equals to the cardinality of A plus the cardinality of B subtract the cardinality of A intersect B. Now what does all that mean? You can memorize the formula and get away with that for a while, but it's going to confuse you if you don't get a picture diagram in your head of what's going on. First of all, A has a set of elements inside of its set. Maybe the numbers 2, 3, 4, 6, 8, whatever. We can set that up. A is equal to these numbers, 2, 4, 6, 8, 10 as an example. That's a set A. Let's make set B equal to, we'll have some intersection here, so we'll do set B is equal to, say, 8, 10, 12, 14, 16, 18. So we have two sets. We're going to think about them abstractly without the numbers, but I want the numbers there for the example's sake. Let's start with pictures though. Let's draw a picture of what they're trying to describe here in formula, mathematical formula here. Oh, and these are the elements of the set. So the cardinality is just the number of elements in the set that are unique. So we have 1, 2, 3, 4, 5. A's cardinality would be 5, and B's cardinality alone would be 1, 2, 3, 4, 5, 6. Okay, and you can't just simply add them together because they have some overlap. In a picture, it's going to look like this. We have set A right here. We have set B, which is this, but there's a portion of them that intersect. Which ones? We have 8 and 10 up here, and we have 8 and 10 down here. So the number 8 and the number 10 are actually intersecting. We can't count those twice. That's why we subtract out the intersection once. So what you would want to do, probably by gut instinct, is to say that the union of A and B's cardinality is equal to, and if you drew the pictures out, you would say, well, that would be A plus B. But that's simply not true because now you're counting the 8 and 10 portion twice. You're saying that the cardinality of A, which is, what did we say, 5? Which is 5, plus the cardinality of B was 1, 2, 3, 4, 5, 6, which is equal to 11. That is not true. We can't count the 8 and 10 twice. We have to subtract those out at least once. Because what's going on picture-wise up here, if we're looking at the picture, we have an entire set A that we're counting all of the A's, 2, 4, 6, 8, and 10. And we have all of the B's, which is 8, 10, 12, 14, 16, 18. Since we counted the 8 and 10 twice, we can't just simply add up these cardinalities together. We have to subtract out what they have intersecting. What do they have intersecting? They have a set of 8 and 10. So we're going to subtract that out once. Because the 8 and 10 are here, 8 and 10, and the 8 and 10 are also right here in B. When you combine them to look like this, they overlap. So they only count once. So right now I'm counting 8 and 10 when I say all of set A's cardinality. And then I add all of set B's cardinality, which is counting the 8 and 10 again. So since we counted it twice, we subtract out one version of that. We are just going to cut this piece out, pretend it was never part of B, even though it is. But when you want the cardinality of the combined union of these two, you have to subtract out the 8 and 10, which I just did here pictorially, so we don't need to actually put the formula in there, because what we have is what we actually want. All of set A plus everything in B that's not an A. And that's this formula here, which is the Inclusion Exclusion Principle. So when you look at this principle, think about this picture here, A and B, and the intersection. Just remember, you're always counting the intersection twice if you do it like this, which does not work. Hope this helped clear up the Inclusion Exclusion Principle. In the next version of this tutorial, I'll do a triple union with A, B, and C.